Okay, it is started. Okay, before going into the foundation engineering course and the introduction of that course, we will revisit and briefly revise the geotechnical engineering 1 and also geotechnical engineering 2 concepts here. So let's start with a discussion on what we learned and what we discussed in our geotechnical engineering 1 course. Anyone who wants to contribute into the discussion, that will be counted as your class participation. What we learned and what we discussed in our geotechnical engineering 1.
Sir, in geotechnical engineering 1, we have studied about soil and its
Sir,
different properties, like its permeability, sir, and also the internal property like void ratio, density, etc., etc.
Excellent. So Imtiaz is saying that our focus was on the basic geotechnical properties of the soils. So that was our main focus. Anyone wants to add?
excuse me, sir.
Yes, please.
Sir, then we classify the soil on the basis of the particle distribution, their property.
Excellent. So then we move towards the particle size distribution, grain size distribution. We also discuss the hydrometer analysis, and then we draw these plots where we can determine the different coefficients there, and we can also classify the soils that, for example, whether it's poorly graded, whether it's well graded. Excellent, Ijaz. Anyone else wants to add? What else we studied in geotechnical engineering 1?
Sir, we study different classification. Let's suppose H2 classification and CSU, that kind of classification, and we study also the tests and limits such linkage limit or plastic limit. All these things we cover in geotechnical engineering 1.
Excellent. Okay, thank you, Adil. Then we moved toward the soil classification, and we used different systems to classify the soils. And as Imtiaz mentioned, we also touched on the permeability of the soils, which is also important. So that was all which we discussed and we learned in geotechnical engineering 1. Then we moved towards a bit advanced, which I call that the properties of the soil, and we studied the geotechnical engineering too. So what were the contents or the basic or the core concepts which we absorbed and we learned in geotechnical engineering too? Anyone?
Ji, sir.
What we learned in geotechnical engineering too. I understand, and now we understand that in geotechnical engineering 1, our main focus was understanding the origin of the soils and understanding the phase relationship of the soils and to determine the basic geotechnical properties of the soils. And also we classified the soils, we find out the liquid limit, plastic limit, and shrinkage limits of the soil. That's good. We also focus on the compaction characteristics of the soils. If you remember, we find out the standard and modified Proctor test there as well to find out the maximum dry density and the optimum moisture content of the soil. Then we move towards the seepage and the permeability of the soil as well, because these are important in terms of cohesive soils and cohesionless soils. Now, after studying this, we move towards geotechnical engineering 2. So what we studied in geotechnical engineering 2, I don't want these specific topics or the specific concepts, but the core concepts, the important concepts which we need to go into the foundation engineering course. That is important.
Excuse me, sir.
Ashad Zawar Khan.
Sir, we studied. May I, sir?
Yes, please. Can you hear me? Ashad, can you hear me? Please proceed.
Yes, sir. Sir, we have studied about the different properties of soil, and one of the main thing is that we have learned about the consolidation and different
Excellent.
type of stresses like shear stresses that are produced in the soil, and the slope failure. What are the factors that cause the slope failure?
Excellent. Anyone else wants to add? Thank you, Ashad. Anyone wants to add into this discussion?
Sir, in geotechnical engineering 1, we make our background about the soil, and in geotechnical engineering 2, we made proceed further. We determined the bearing capacity and did some kind of tests, and let's suppose direct shear test and van shear test, all these kind of we did in geotechnical engineering 2, and find the consolidation, a lot of tests in geotechnical engineering 2, sir.
Adil, thank you very much for the discussion. But how we find out the bearing capacity in geotechnical engineering too?
फाइल लोड टेस्ट के जरिए सर फाइंड करते हैं सर.
Okay, so you are talking about the lab there. So, okay, that's fine. Now I understand. Okay, in geotechnical engineering 2 theory course, what was our main concepts? Ashad, Zawar, and Adil highlighted a few things which are more relevant to the geotech 2. So what were the other kind of tests we discussed there, and what were the core concepts which we were interested in to learn and to teach? Maybe one or two more students, that will be more than enough. Yes, please. Tosif.
Yes, sir. Sir, in order to find the settlement in the soils, we perform tests like audiometer test, and from that tests we find the consolidation in the soil, and for the shear stresses.
Yes, sir. Sir, we have already studied about triaxial test and combined.
Okay. That's good.
Test, like
that's good.
Strength in the soil.
Okay, so
we have studied in geotech 2 also.
Okay, that's great.
Triaxial tests are confined compression tests, unconfined compression tests.
Ashad, please wait for the turn for Tosif, because Tosif didn't finish his explanation. So I will give the chance to everyone. Thank you so much for your participation. And but let us give a chance to Tosif. So let him complete his explanation and discussion. Then you can also contribute. Okay, please wait. Tosif, please explain.
Okay, sir. So, sir, then after consolidations, we study about the shear strength, and in order to find the shear strength, practically we perform different types of the tests, like direct shear test that was quicker, but it was not giving the good results about the shear test. Then we just moved towards the 1D consolidation tests, and in order to find the shear strength in the soils, we performed triaxial tests that have also different types and different methods to be performed. So
Excellent.
we study about all these stuffs.
Okay, thank you very much, and thank you, Ashad, for mentioning the test, which is very important, and we discussed in great detail. Nihar is saying that simply we can say that in geotech we studied that how the soil will respond if load is applied or if we construct something over it. Excellent point, Nihar. Thank you very much. Now, shear strength parameters were determined using different types of tests. As you all mentioned, direct shear test, triaxial test, vein shear test, standard penetration test. So those tests were then performed. So if you look the transition between Geotech 1 and Geotech 2, you can clearly see that we are moving towards the basic properties, towards the advanced shear strength properties. Now we are building a foundation on that soil. So in order to build a foundation, a geotechnical engineer must know the basic concept, for example, the basic geotechnical properties and the shear strength properties of the soil, right? Now, this is a good point that we can move towards the foundation engineering, that what we are going to expect. This is just an introductory class, just to give you an overview that what we are going to study in the coming classes. So as the course aims says, that the basic aim is to enable the students to estimate the bearing capacity of soils. We will discuss bearing capacity in great detail. We will determine the size of foundation. We will determine the size of shallow foundation and deep foundations. Deep foundations are also known as pile foundations, which is adequate for meeting bearing capacity and settlement criteria. Bearing capacity is one criteria and the settlement is the another criteria. Then we will having 3 CLOs related to foundation types and selection, foundation loads, bearing capacities, different bearing capacities equations, soil failure modes, and foundation settlement, field test, and soil improvement techniques. Now in CLO2, we will apply those concepts which we learned in the previous CLO. We will apply those concepts of the bearing capacity equations, field test data, settlement formulae, and to estimate load carrying capacity of the shallow and deep foundations. In the third CLO, we will focus on evaluating different types of foundation systems according to the field conditions and stability of the retaining walls in terms of translational, rotational, and bearing capacity failures. Now, the teaching activities, you all know that we will take few quizzes, and most probably 2 quizzes and 2 assignments would be there, because it's a 2 credit hour course. Classroom discussions that is needed for sharing the knowledge with each other, and if you use different wordings, I personally believe that you learn more when you contribute in the discussion. So that helps a few students that are hesitant to ask questions, are silent there, are introvert kind of students, so it helps them as well to learn a few things which they are unable to ask. In class activities will also be done. Sometimes you will be given a problem there, so you can solve, you can discuss. Homework assignments, group assignments, presentation by students, maybe I don't know if it's feasible in this course, but let's see. We will, this is an option that we can go for that as well. Reports and self-study, any other suitable mean not covered above midterm and final comprehensive exam. So these are all the activities which we can focus on to learn and to deliver this course. So we will first start with the introduction, which is today, the first week of our today's class. We will focus on the definitions and purpose and types of foundations, general requirement of foundations, steps in the foundation design, selection of the foundation type, and loads on the foundation. So this will be our today's topic. Definitions and different types of bearing capacities, soil response to a loaded footing, methods of obtaining bearing capacity, collapse load using the limit equilibrium method will be discussed in the second week. Then we will move towards our important lecture, which is Terzaghi bearing capacity equation theory, and we'll solve examples on the Terzaghi's theory as well. Different effects, and then we will move towards on another important lecture related to the shallow foundations, which is the Meyerhoff's theory of bearing capacity, that how we can use the shear strength parameters and how we can find out the bearing capacity using the Meyerhoff's theory of bearing capacity. Now, effect of load eccentricity on the bearing capacity, inclined loads, and a few examples will be solved on this theory as well. After discussing those two theories, we will move towards the different design philosophies, for example, allowable stress design, limit state design, and we will solve a few examples on these philosophies as well. As we discussed in Geotech 2, the settlement, now we will find out this settlement, and we will also discuss the different components of the settlements, for example, immediate settlement here, and how that immediate settlement can be found out using different examples. Different field tests will also be discussed, that how we can find out the bearing capacity from the SPT test, and how the N value can be helpful in the design process of the foundation. Plate load test and its applicability in the foundation engineering will also be discussed in the 7th week. Now we will solve a few examples on it, and then we will move towards the midterm of the course. After midterm, primary consolidation settlement, time rate of settlement, and how it affects the foundations, different types of retaining walls, and stability of the rigid retaining wall, backfill drainage will be our topics after the midterm. A very important topic which will be discussed, different types of deep foundations, and in deep foundations we will discuss types of pile foundations, methods of construction of the pile foundations, how the load capacity of the piles are derived, and how we can find the bearing capacity of the piles, driven piles, types of hammers, selection of the hammers to construct or install the pile foundation will be focused after the midterm. Static capacity of the piles, negative skin fraction, pile load test, efficiency of pile groups, so if it's installed or constructed individually, how the capacity will change and how the capacity will increase if we construct a group of piles in the particular soil. Things will be discussed in detail, the compaction and the compaction methods. If you remember different methods, and I really enjoyed your animations in the Geotechnical Engineering 1 course. I don't think so that we will reach to this this part in the 17th week, which is given in the standard course contents. But let's see, you know, I think so we covered that in a very good detail in Geotechnical Engineering 1, and we already know that how the compaction and the compaction, fiber replacement, dynamic compaction, adding slime, cement, fly ash stabilization, preloading, vertical drain, just good grounding can, you know, change the density and the shear strength of the soil. The grading criteria is the standard grading criteria for all the other courses. Now the syllabus and the recommended books are also given here, and the document is already shared with you people, so you can read that document in detail if I'm going a bit quicker on it. Okay, the Soil Mechanics by R.F. Craig is a standard book. Soil Mechanics and Foundations by Buddu. You can also read that book as well. Foundation Analysis and Design by Bowles is also a handy book to read for the foundation engineering course. Now, it's highly recommended that, you know, you don't limit yourself for the course just to the course notes. You can go and watch online videos. Lots of good literature is available nowadays due to the pandemic and COVID-19 situation. Lots of international professors, they have uploaded, you know, videos and lectures there, so that is also a good means to enhance and increase your awareness and understanding. So that is all about the course contents. Now we will move towards the introductory lecture. Okay, please confirm that you can hear me and the screen is visible. One person.
Okay, sir, it's visible. And we
Okay, that's great. Now,
Yes, sir.
in starting the introduction, consider this as a frame. Okay. Here we are given with a frame here. Here, this one. You can see here. Now, this frame is transferring the load to the soil present here. For example, this one is also transferring here, and this one is also transferring to the soil. Now, the dimensions are given. We are given with 1 feet into 1 feet cross section of that column, the middle column, and it says that 40 tons of load is applied. Now we need to find out that whether that soil can take that load without any shear failure, and also without any settlement problem. How we can do that? So the ultimate pressure that will cause shear failure of the soil is 10 ton per square feet. So this is the, we can call that Q ultimate. Now the factor of safety, we will discuss in great detail about the factor of safety just below the page or the slide, we can call that. So if we take the factor of safety of 4, so we will divide the ultimate by the factor of safety, and we will get 2.5 here. So this is the allowable, or we can call that as Q allowable. Okay, it's 2.5 for the shear failure. Now the allowable pressure intensity to limit the foundation settlement is for 1 inch or 25 millimeter. Okay, that is 1.8 ton per square feet. So for shear failure, we are given with the 2.5 ton per square feet, and the allowable pressure intensity or allowable bearing capacity for the settlement criteria is 1.8. Now these are the two design criteria in the foundation. In order to build that foundation, we need to satisfy these two criteria. Now if we place this column directly on the ground, and we already know that the area is 1 into 1, so 1 square feet. Now the pressure will come here 40 ton per square feet. So the allowable for the shear failure criteria, it was 2.5. For settlement, it was 1.8. Here we are experiencing 40, which is huge. Okay, I think so this one must be corrected to 1.8 ton per square feet. You can do that. Now we are in big trouble, because 40 ton per square feet is too huge to be transferred to this soil. So it's unable to take that load. What could be the possible solution? Solution can be that if we provide a widened area here beneath the column and we increase the width of that. So one option is to increase the width of this column till top. So this could be one option. Now that is uneconomical. Okay, costly. So this is the option 1, I would call it, and this one is the option 2. So which one you will pick and why? This is the option 1 and this is the option 2. Which option you are going to pick and why?
Option 1.
Why?
सर उसमें हम उस पेड़ की सर एरिया को बढ़ा देंगे तो ज़्यादा तर एरिया पे वो लोड डिस्ट्रीब्यूट हो जाएगा.
Anyone else? Anyone else?
सर ये ऑप्शन 2 दोबारा से थोड़ा बता दे सर.
Option 2. Okay, let me redraw. Okay, let me redraw. Okay, let's redraw that with different colors. So this is the option number 1. Okay. And the option number 2 is the bluish one. This one. So which option you're gonna pick? Please remember this.
So second one. Sir, second one foundation wala sir.
Okay, this one. And why?
Because sir जब लोड कॉलम से जब डिस्ट्रीब्यूट होगा सर इस पे फाउंडेशन पे सर, तो कुछ लोड उस पे ट्रांसफर होगा, उसके बाद फाउंडेशन के बाद वो कुछ लोड जो है जमीन पे आएगा सर.
Okay, can you please repeat, because I got a call, that's why the internet got disconnected.
सर फाउंडेशन सेकंड ऑप्शन जो है सर वो आई थिंक इट्स राइट आंसर. वो ये कि मतलब क्योंकि ये होगा कि मतलब जब कॉलम से लोड ट्रांसफर होगा फाउंडेशन पे तो उसके बाद वो लोड जो है वो फिर लोड जो है वो जमीन पे आएगा सर. तो इसमें ये होगा कि मतलब आधा लोड जो है वो क्या नाम है इसका फाउंडेशन ले लेगी और उसके बाद आधा जो है वो सॉइल पे आ जाएगा सर.
Excellent. Look, the thing is that we were given with the option number 1. The option number 1 is to increase the column width from bottom till top, but that will be very, very costly option because we are going to use lots of concrete there and that will increase the cost of our project. Instead of that, we can increase the foundation width here, and then we can see and check that whether this soil is going to take this load or not. And then we are given with the two criterias for the shear criteria and for the settlement criteria. Okay, so that's what we are going to discuss here. For example, if we increase the width of the fitting by 5 feet, initially it was 1 feet, so the area will be 25 feet, and now the pressure intensity will be 1.6. I would write somewhere here 1.6 TSF. Now you can clearly see that 1.6 ton per square feet is less than this criteria, which is 1.8. It is also less than 2.5. Agree? So now we are good, and the factor of safety is increased, because if you divide that 10 per square feet, which was here, which is the ultimate pressure intensity, and the allowable pressure intensity is 2.5, basically the factor of safety has increased significantly. Now, one more thing which we need to consider, that for the shear failure criteria, the allowable pressure intensity is 2.5 ton per square feet. And for the settlement criteria, it is 1.8 ton per square feet. So which one is the governing criteria? The governing criteria means that we need to focus as a geotechnical engineer on the smallest bearing capacity value. So this will be the criteria which we will be focusing on more, because if we pass this, automatically the criteria will change. So we need to look here that 1.6 should be less than this settlement criteria. So that's why we call that as the governing criteria. Agree? Okay, now what we can do here, okay, now let's take the bluish one. So how to calculate the ultimate pressure intensity that will cause the shear failure of the soil will be discussed in chapter number 2. Okay, that
सर स्क्रीन शेयर करें
स्क्रीन शेयर करें
okay. Can't share the screen. What happened? चेक करें यार इसको. Please confirm if it's visible.
sir.
Okay, it's done. Okay, thank you. Chaudhary Sadmir. Okay, good. Is it visible now?
Yes, sir.
Okay, thank you. So in chapter number 2, our main focus will be on the shallow foundations. In chapter number 4, our focus will be on the pile foundations. And in chapter number 3, we will discuss about the foundation settlement, and the settlement of the deep foundation or pile foundation will be discussed in chapter number 4. Now, why we assume higher factor of safety? So we discussed here that factor of safety is needed let's take this one here.
Screen, sir.
Let's take into a short discussion why we need factor of safety. Let's
Sir,
suppose
screen
3
share
cells.
करें, sir.
Let's suppose 4.
सर स्क्रीन का मसला फिर से आ रहा है सर.
Anyone, why we assume factor of safety 3 or factor of safety 4 in the design of the foundations?
सर स्क्रीन शेयर करें सर.
इलेका सर्वे डिस्कशन को सोपले जवाब वर्की.
Ashad, Nihar, Tosif, Khalid.
Okay, sir. Sir,
Again,
more
the screen is
such,
gone. I don't know why.
सर मैं आंसर दूं सर.
नहीं आ रही यार, आपकी आवाज तो बिल्कुल नहीं आ रही.
वाया कने सीनियर वर्ता जवाब
पता
वर्का.
नहीं कुछ मसला है यहाँ पे. आई डोंट नो
Zakhwala
ये क्या मसला है.
jawab.
मैं यहाँ से स्क्रीन कर रहा हूँ और आपकी आवाज मुझे नहीं आ रही है.
सर हमारी आवाज आ रही है आपको सर?
नहीं, बिल्कुल.
हेलो सर.
अच्छा, मैं जो है ना वो फिर क्लास डिस्टर्ब हो जाएगी ना यार, कोई वो तो मसला है ना. वो फिर रिकॉर्डिंग भी डिस्टर्ब हो जाएगी और इसमें इंटरप्शन भी आएगी, तो लेक्चर डिस्टर्ब नहीं हो जाएगा सारा. अच्छा, आप इस तरह करें कि आप सारे जो है ना वो डिस्कनेक्ट हो जाएं और आप रिज्वाइन करें. ठीक है, आप इस तरह करें कि आप सारे थोड़े टाइम के लिए 1 मिनट के लिए लीव करें सारे. ठीक है ना. प्लीज काइंडली लीव द क्लास. प्लीज काइंडली लीव द क्लास एंड देन रिज्वाइन. Please kindly leave the class and then rejoin as soon as possible. ठीक है. स्पीकर मेरा जो है ना वो ऑन है.
Please confirm, can you hear me?
Yes, sir.
Okay, thank you. Mohammed Farhan, can you hear me? Rahmat Shafahad. Can you hear me? Ahsan Shahid.
Yes, sir, we can hear you.
Okay, then please kindly text in your group there that join as soon as possible. I don't know what happened, but for some reasons you were unable to hear my voice.
Okay, sir.
Please kindly text them so that we can start with the remaining lecture. We will wait for a minute here. So please kindly tell your friends to rejoin and reconnect. And then we will start with the remaining lecture. Khalid Mahmood, your camera is on. Can you hear me? Okay, that's good.
Yes, sir, you are for this, absolutely.
Okay, no problem. Okay, so we will start with the remaining lecture. So our question was that why we use the factor of safety. So factor of safety is dependent upon, there are different reasons that in soil we might have the natural variations. Okay, please don't talk. No problem, it's okay. Okay, so we have the natural variation of the soil properties. Sampling and testing techniques are not perfect. For example, we discussed about the standard penetration test and the sampler issue in geotechnical engineering too, that can lead us to the disturbed samples. The theories, lots of assumptions are applied in driving those theories. That's why we apply the factor of safety. And we all know that it's very costly. The foundation failures are difficult and expensive in repairing them. So that's why factor of safety is assumed. Now, what is a foundation? It's a structure which will transmit. If we say that this is a superstructure, this is the superstructure. So the part of the
screen share नहीं है sir.
यार खुदा का खौफ करो यार, क्यों शेयर नहीं है? देखें ना यार.
नहीं है सर, नहीं आ रही सर.
अच्छा, ये ऑफ हो कैसे जाती है?
सर से शेयर नहीं दिया, अभी शेयर हो गई सर.
अच्छा, तो बता देते ना पहले से यार. नहीं, मैं तो इसको ऑफ नहीं कर रहा, ये ऑफ हो कैसे जाती है ऑटोमेटिकली? क्योंकि मैं तो वैसे भी यहाँ पे लेक्चर दे रहा हूँ, तो ये ऑफ कैसे हो जाती है? खुद ही हो जाती है कि क्या मसला है? एनीवेज, ठीक है. तो हमारे पास वी हैव ए superstructure here, and that superstructure is applying a load onto that foundation here. This part is known as the foundation. Now, how the foundation engineer can design the foundations. You
सर वो
need
इससे पहले आपने जैसे ही राइटिंग शुरू करी वो
अच्छा खुद ही हो गई यार एक और काम कर लेते हैं चले
और अभी ठीक है
अभी ठीक है चले ठीक है प्लीज ओके चले इसको देखते हैं अगर तो हम कुछ कर नहीं रहे हैं तो anyways so in order to be a foundation engineer you should be sufficiently trained and you should gain sufficient experience to design the foundation. You also need to know the scientific principles, okay? Scientific principles related to the basic geotechnical properties of the soil, the scientific principles related to the shear strength of the soil. You should know the consolidation behavior of the soils, and you should have the engineering judgment that how the foundation will transmit the loads to the soil. Now, in order to gain the scientific principles, the knowledge, understanding here, you need formal education courses related to soil mechanics and geotechnical engineering, geology, and foundation engineering. You also need to know a little bit about the analysis, design in reinforced concrete and steel structure, which you will study in the 8th semester. Engineering and continued self-study is also recommended and the short courses. Now there are two types of foundations. Let me show you something here. Here you can see that a shallow foundations, you can note down this information if you want. This is the shallow foundation. So there are two types of foundations. One is the shallow foundation and one is the deep foundation. Okay, so if the depth, let me take this one. If the depth of the foundation is less than or equal to, or I can say here, I think so I have written it here somewhere. Yeah. So if the for shallow foundations, the depth to breadth ratio should be less than or equal to 1 to 3. In notes it's written that it's 1, but it's also written that somewhere 1 to 3. So if you write less than or equal to 1, or if you write this one, so it's more practical, I guess. For the deep foundations, the length, which is also equal to the diameter, which we can see here, that you can length of the pile, I would say, that's right, I guess, pile here, still F. Should be the pile one, or you can say foundation as well. Okay, that's fine, that F is foundation. Now, so you have noted down this information, length or the depth divided by the breadth of that foundation. If it's greater than or equal to 4, that is known as the deep foundation. And if it's less than or equal to 1, it is the shallow foundation. Now, there are different types of shallow foundations depending upon the shapes and to transfer the load.
Sir,
Yes, please.
deep foundation और column में क्या difference है?
Excellent point. Deep foundation और column में क्या फर्क है? Excellent point to discuss. Anyone who knows about the column and the deep foundation pile? What is the difference between a column and a deep foundation? किसका क्वेश्चन है?
मेरा सर.
इश्तियाक अहमद.
Yes sir.
Anyone who wants to contribute into the discussion?
सर कॉलम शायद सुपर स्ट्रक्चर में होता है सर, और जो फाइल है सर वो सब स्ट्रक्चर.
Anyone else?
सर जो हमारे पास कॉलम्स होते हैं इसमें जो लोड ट्रांसफरिंग होती है वो प्योरली इंड टू इंड होती है, जबकि पाइल फाउंडेशंस है उसमें ये केस नहीं होता, उसमें इंड टू इंड लोड ट्रांसफर भी हो सकती है, फ्रिक्शंस के थ्रू भी जो है फोर्स ट्रांसफरिंग होती है सॉइल तक. तो आई थिंक यही मेन डिफरेंस है.
Anyone else? I would say if you see here, where is that figure? Here. So if you see here, this is looking like a column, but if you see, it's constructed into the soil. So for example, if we are constructing a building on top of these piles, here, and if this is a column here, first one and the second one, and for example the third one here, this is another story here. So we can call that as in a superstructure, this slender type of structure is known as column. But when you install the same column in the foundation, in the soil, then you can call that as the deep foundation or the pile foundation, and then you can install number of piles here into the soil as well. So basically it's all about the superstructure and the foundations. Now in single,
एक्सक्यूज मी सर.
yes please.
सर आपने जो पाइल फाउंडेशंस कहा कि ये कॉलम्स भी होते हैं लेकिन ये सब स्ट्रक्चर्स में होते हैं. आई थिंक जो हमारे पास कॉलम्स होते हैं वो तो उसमें जो लोड ट्रांसफरिंग मैकेनिज्म होती है वो तो टोटली डिफरेंट होती है ना पाइल्स में.
नहीं देखें, मैंने कहा कि अपेरेंटली मैंने आपको बताया है कि देखें आपको लुक अलाइक ऐसे है, बाकी इसका मैकेनिज्म लोड ट्रांसफर वो तो हमने स्टडी किया ही नहीं है, क्योंकि हम तो इंट्रोडक्शन में बैठे हुए हैं यहाँ पे. आ रही है समझ?
ओके सर.
उसकी तरफ तो हम देखें, उसकी तरफ तो हम गए ही नहीं है और ना मैं जाना चाहता हूं, क्योंकि ये बिल्कुल इंट्रोडक्शन है. और इंट्रोडक्शन में अगर आप उसको जाना चाहते हैं, ठीक है, उधर यहाँ पे तो हमने अभी उसको क्या कि टाइप्स ही डिस्कस नहीं किए अभी तक, तो हम गए ही नहीं है. ठीक है, तो उसमें हमारे पास लोड ट्रांसफर मैकेनिज्म कैसे होता है, फिर उसमें जो है ना वो फॉर एग्जांपल अगर मैं इसको लेट सपोज चले आप चाहते हैं तो वो तो टोटली डिफरेंट बात है, लेकिन वो फर्स्ट लेक्चर में ना हो तो अच्छी बात है, क्योंकि उसमें फिर हम थोड़ी लेंथ ऑफ द क्लास जो है ना वो इंक्रीज हो जाएगी. लेकिन कोई मसला नहीं है, अगर लर्निंग हो रही है तो अच्छी बात. देखें वो तो सुपर स्ट्रक्चर की तरफ तो जो है ना कॉलम में तो हम जाएंगे ही नहीं. ठीक है, अब यहाँ पे लोड लगता है, फिर यहाँ पे जो है ना
इंट्रोडक्शन होता है
सर आपकी वॉइस भी लैग कर रही है सर।
स्ट्रक्चर आ जाता है, ठीक है, यहाँ पे कॉलम आ जाते हैं, तो उसकी तरफ। अच्छा, अभी क्लियर है कि नहीं क्लियर? इज इट क्लियर नाउ?
जी जी।
Yes, sir.
So this is how the load is transferred to the soil. मैंने तो आपको बता दिया कि first of all, you know, the load transfer mechanism is different, the installation methods are different, obviously, that's why, and even the shapes are different. I would tell you one thing more, that in research, sometimes, you know, they apply helical piles there. So these are known as the helix, and the load mechanism is also different in case of soil. It's totally different, and we will discuss that in chapter number 4. Now, going into the different types, okay, of the shallow foundations, there, you know, if you want to transfer that load, it can be a spread, single, or isolated footing. There are different shapes of the single or isolated footing. You can see there are steps involved. It may be slopey as well. There are other different types of spread footing here in D, and where the pedestal is applied just to have that load transferred in a steel column, and in order to avoid the corrosion here at this intersection. And the slope, that is just to reduce the cost. Okay, they are economical, as it's mentioned here. They are economical, so usually people prefer to construct these single or spread footing. Now, if we want to construct a wall footing, so it's simply the base is thickened a little bit than the wall, and it will act as the wall footing. You can make either from the reinforced concrete or the brick masonry. Now, in combined footings, there are two types, I would call that the rectangular, it can be in rectangular shape or it can be in trapezoid shape as well. Sometimes the column cannot be placed at equal interval. For some reasons, if you want to place equipments here, or if you are having non-uniform distribution in the soil, sometimes the load will be, for example, greater in one case, or sometimes P1 can be less than P2. Now, in these cases, what will happen? We need to use the combined footing. Okay. Now, in order to have the uniform distribution beneath that footing, we combine this foundation. Okay, sometimes you can use that as a rectangular, or sometimes you can use as a trapezoidal. How and why? For example, the P1 is greater in this case. So if I would say here, now, and here we are having a property line, and load is greater on P1. So it's better to increase the width here so that the loads will be transferred to the soil uniformly, and it won't cause the non-uniform or the differential settlement in the foundations.
third one can be a scraped foundation here, in which we can reduce the amount of concrete which is used in rectangular foundation. So you can simply provide, let's suppose like this, a strap here, and you can remove this portion and this portion. So as you can see, we can save few bucks on providing the strap here instead of a rectangular or trapezoidal combined footing. Now, usually the constructor companies avoid such kind of structures and such kind of foundations because the formwork is very expensive and it's difficult, it's time consuming. So people go with the rectangular and simple foundations. Now, again, if you see here, you can apply P1 and P2 and how you can find out the centroid. And just let me tell you that this kind of analysis will not be tested and will come in the examination and just give you an overview that how structural engineers do the analysis for the foundations. So our main focus will be on the ultimate bearing capacity, allowable bearing capacity, and what are theories are used here in finding the allowable and ultimate bearing capacity. So the details are given here for the strap foundation and all the reasons that people will avoid the strap and trapezoidal foundations. Now, structural engineers need a value from a geotechnical engineer. This is the value. This is the allowable bearing capacity value. He needs only this value to put into his calculation, and then he can find out the dimensions. For example, the length and the width of the footing. And based upon that, he can transfer the dead load, the live load, the moments due to the dead load, moments due to the live load, load which is applied here, and the ultimate load and the ultimate moments. Now, how we reach to this Q allowable? For example, let me draw here. So we use theories, or I would say bearing capacity theories. Now, this is the one step, but for bearing capacity theories, what we need? Can you hear me? Please confirm.
Yes, sir.
Yes, sir.
Okay, so what we need then for bearing capacity
Yes,
theory?
sir.
What we need for the bearing capacity theories? We need shear strength parameters. Okay, shear strength. Now, for shear strength parameters, how we find out shear strength parameters? Lab and field tests. Now, what kind of lab or field tests? So you can clearly see that lots of steps are involved here in order to reach to that one value. Okay, this is one value, and if I'm not wrong, the chapter number 2 or even the chapter number 4 will be focusing on the allowable bearing capacity and all the efforts which we make to reach to that one value. We spend a lot of time on the shear strength and the shear strength parameters, different types of triaxial, different types of tests like direct shear and unconfined compressive strength tests were discussed in the previous class, in the previous course, in fact, the geotechnical engineering 2. Then a structural engineer apply some dead load, the factors to dead and live loads, because there can be variation in the dead load and the live load, and we can find out the ultimate bearing capacity using this equation, because the allowable bearing capacity is given. But once we do that, we can find out the centroidal distance as well. And if we take the moments at one column, then we will find out the resultant of these two loads which are acting at a certain location. Okay, and once we do that, we can use these equations. Structural engineer use these equations to find out the length, and as we know that the P ultimate is equal to BL into Q ultimate, or Q ultimate is equal to P ultimate divided by the area. So you can find out the breadth of the foundation as well. So this length and for this breadth or for this area, this is the allowable bearing capacity of the soil. Now for that loading conditions, the working loads, this is the Q allowable, and now this one is the foundation dimensions. Just to let you know that all these things will be discussed in very good detail, and the example problems will be solved related to, because this is the structural engineer part. Geotechnical engineer deals directly, or in this course our focus will be on these two, on the Q allowable and the dimensions. Now if the soil conditions are erratic or very weak, this is one criteria for the mat foundation. For example, these are the mat foundations, different types of mats which are provided, and these kind of structures or these kind of foundations you will see in high-rise buildings. For example, if you go to any mall construction, you will see such kind of foundations which are under construction. Now, for example, if these are the single footings, and if the 50% area is covered by single or spread footing, then it's better to go for the mat foundation or raft footing. Now, it's a bit costly, it's uneconomical, because we need to provide both the positive and negative reinforcement in this mat foundation. So sometimes people prefer to use fiber spacer boards in there just to avoid those negative reinforcement or the extra cost to reduce the cost of the project. Now, as I mentioned earlier on, that for the deep foundation, the L by B, or we can say the D by B ratio should be, sorry, that should be greater than or equal to 4. Now, there are different types of requirements for the foundations. For example, the safety requirements, for example, the factor of safety should be considered due to the variation in the soil properties and how these are determined and how the shear strength parameters are determined. Now, the settlement criteria should be fulfilled in case of settlement and total settlement. The foundation should be designed in such a way that it will not affect if settlement occurs, significant damage shouldn't occur, because if the structural failure occurs, then it's very costly to repair these kind of structures. So that's why for the safety requirement should be considered, for example, factor of safety, settlement, and the structural failure should be avoided. Now, there is another criteria also, and that requirement is also there for the depth requirement. Now, for example, if we place a foundation in such a condition in northern areas of Pakistan or even in Balochistan, please confirm that you can hear me and the screen is visible.
Yes, sir. Yes,
Thank you very much thank you for your confirmation. Now, for freezing and thawing condition, now in northern areas, the depth requirements will be different because sometimes it will snow in that area, and here in case of the Balochistan, there won't be any snow, so we need to consider the zones that will not affect the volumetric changes which is occurring in the soil. Footing should be below zones of high volume changes due to moisture fluctuation. We already know that there are certain types of soils which will definitely change the volume due to addition of the water into that soil. Sometimes, the high plastic soil shrink on drying and swell upon the addition of moisture. So these kind of soils are known as expansive soils, or the problematic soils, which can significantly create, the differential settlements in the soils with the addition or the drying up of the water. Now, in order to prevent the erosion from wind, and water, a sufficient depth provided beneath the surface of the soil. Now you can make a slight correction here. It should be an expansive soil with A instead of E. Expansive soils, as mentioned earlier on, if you add water into the expansive soil, significant volumetric change will occur. It will expand, and when the water is dried up in that clay, then it will have a significant shrinkage, and due to this shrinkage, differential settlement will occur in the formations. So such soils like peat, organic soils should be avoided. Soft unconsolidated deposits should be avoided in order to have significant settlement issues in the foundations, and it should be provided with a sufficient depth. Prevent footing movement distortion by plant, or you have seen somewhere, in local cases, sometimes you will see that the tree root has grown up so much, and it has disturbed or cracked the foundational buildings. Spacing requirements, we discussed in geotechnical engineering 2 about the pressure bulbs there. So therefore, spacing requirement should also be considered in the design of the foundations. Now, what are the steps for designing a foundation? Or locate the site and the position of the load. Like how the things are going on at the site. Then, if we are unclear, we will go for establishing a field exploration program. So what are the field exploration programs? We will go and see that, for example, we can perform the standard penetration test, cone penetration test, vent shear test, and what type of test, for example, the lab moisture content test, specific gravity test, liquid limit, plastic limit, and shrinkage limit test. We need to perform grain size distribution, and we need to perform unconfined compressive strength, or we need to perform the triaxial tests. Then we will determine the soil shear strength design parameters, cohesion and friction angle, unit weights, etc. We can find out the plasticity parameters, and then we can input those values into the geotechnical softwares. There are different types of softwares which are used. For example, one of the important softwares which is used mainly in USA and Canada is the Fluxys. So Fluxys is one of the softwares which you can use. GeoStudio is the other software which you use for the ability to perform very good analysis on shallow foundations, deep foundations as well. For the foundation selection process, we will go through the structural design, environmental effects, and subsurface conditions, performance requirement, construction methods, and economics. And then for the foundation selection process, I think so it's good to go for this figure instead of the text. So first of all, we obtain the site information like the surface and the subsurface information, obtain the structure data, what type of structure it is, what is the performance criteria, foundation loads, and then we move towards the evaluation foundation alternative. Should we go for the shallow foundation? Should we go for the deep foundation? If it's not working, then we go for the ground modification for the shallow foundation, or even if it's not working, then we can go for the ground modification for the deep foundation as well.
सर आपकी आवाज नहीं आ रही सर.
If it's not feasible, okay.
अब सही हो गई सर, अब आ रही है सर.
Okay, thank you very much. Thank you for the confirmation. Now for the recommendation, if it's acceptable, then it will go for the recommendation, for example, the foundation type, design data, and the construction procedures. At last, we will prepare a detailed design plans and specifications, and then we will monitor the construction. So that is how the foundation process goes on. So you can read a little bit the text there, which will take a little bit more time. Now, in North America, when you graduate, like if you complete a undergraduate degree, then you straight away go for a junior geotechnical engineer position. Now, the main job requirements or responsibilities are to perform the basic geotechnical test which you have performed,
in geotechnical 1 and geotechnical 2, and also the running the analysis using Plaxis or GeoStudio. So if you know these things, you can easily immigrate to Canada or Australia as well, because this is the job of the geotechnical engineer. The important requirement and responsibility of a junior geotechnical engineer is to write a geotechnical report. Now, what does it contain in the report? So you need to report the site description, the boring logs and the subsurface profile, what kind of lab tests and field tests were performed, review the design loads, how much were the design loads given to you by the structural engineer. Then you need to show the analysis of the behavior of each foundation alternative and the cost comparison as well. I guess evaluation of the predicted performance in relation to the performance requirements, discussion of the potential construction problems. For example, if the excavation is being occurred in the nearby area, dewatering or the water table problems as well. Relative costs will be discussed here. Recommendations will be provided. Foundation type is provided. Foundation design criteria, for example, the allowable loads are the depth requirement, the spacing requirement should be provided. Any special construction methods that should be used for the construction of the foundation, construction monitoring if required, that should be done here. Okay, so this was all about the introduction. I hope that it gives you an overview, an idea that what we are going to study in this course. So let me show you a few videos that the world has gone beyond the onshore environment, and the world has gone into the offshore environment for different reasons, for the sustainable reasons, sustainable research which is conducted around the globe on the different types of foundations. So we are focusing here in this course on the basic foundations which we are dealing in the onshore environment, but there are different types of foundations. So I would recommend please kindly, lower your volume here, because sometimes the voice will be a bit higher. So these are different types of foundations which are installed in the offshore environments, and significant research has been done to construct wind farms and wind turbines in the offshore environment in order to avoid the voice issues, the noise issues. So these are also part of the foundation engineering, and geotechnical engineer are hired to do these kind of jobs. These are kind of vacuum pumps. When I was in South Korea, we were working on the dynamic properties of the soil, because waves and wind loadings are applied onto that foundation. So we were given with the task that we need to investigate the basic geotechnical properties, advanced geotechnical properties, and the dynamic properties of the soil. So we went to a river there in South Korea during my master's, and we evaluated the dynamic properties, the advanced shear strength properties, and the basic geotechnical properties during my master's studies. So that is the Norwegian geotechnical engineer. Lots of countries, Norway, Sweden, they have gone to the 100% electricity has been generated by the wind turbines. Another one which will be on the onshore environment, which is related to the onshore environment, they are known as gravity-based foundation. When I was pursuing my PhD at Western University, Canada, so one of my friends, he was working on the dynamic properties of the shallow foundations for the wind turbine foundations, which is located in, I guess, Chatham here, which is close to the US border. So this is the bed which is first constructed. I hope you can clearly see the video and my voice as well.
Please confirm.
Yes, sir.
Okay, so that's how. And the interesting thing is that these types of foundations, the onshore foundations, are also constructed in Balochistan, also in Sindh, Jambir area. So that's how the construction process goes. Because geotechnical engineer is required. You can clearly see the clay soil there. The mineralogy will be different. The color is different. The moisture content is different. The shear strength is different. So if the dimensions, these reinforcements, everything will be dependent upon the type of soil on which the construction is going on. So if they don't hire a geotechnical engineer, they can go, they can even construct and design these foundations, but that will be significantly costlier compared to the information which is gotten from the or obtained from the geotechnical engineer. So that input is also required. So if someone is interested in geotechnical engineering or a foundation engineer, that information is needed. So all the information, everything, almost everything is built on the soil or depend upon the foundation. So now we will see that a massive structure will be created here. So I will go a little bit quicker. So that's how the rebars, reinforcement is done, concreting is done. That's concrete compaction. And at the end, this is the foundation, backfilling, and all this kind of stuff. You just connect the stem here. You just connect the stem here, and these are the wind turbines which will create. This is just then connected to a grid station, and this is the clean and green energy which the developed nations are harnessing from the wind turbines. And there are tons of wind farms which are constructed nowadays in Europe and North America, and especially the Far East Asia. There is an interesting video which I would recommend, and that is related to the Rion Antirion Bridge. So let me pause that video for a few minutes. So that was the video which my supervisor told me to explain to the undergraduate students when I was studying at Western University, Canada. And he told me just to show them the video and tell them that what is the importance and where the geotechnical engineer can be, the experience, knowledge, and awareness of a geotechnical engineer can be utilized even in the mega structures and in the mega projects. So don't think that it's just like the basic geotechnical properties and just advanced geotechnical properties are just, you just say that okay, it's just like performing a cyclic triaxial test. These information is required in order to build these kind of structures. So that was a mega structures, and I will strongly recommend that please kindly watch this video 2, 3, 4 times. Then you will understand that this information is very crucial and very important. So that we need to construct a bridge here. They were taking lots of time there. That's there mentioned there somewhere in the video. So, but the soil conditions was unclear, and it was very deep in that area because it's a narrow area. If you see here, but that water was very deep. So they need to do the soil investigation and how they did the soil investigation. I will that part a little bit to you just for your interest. Anyways, you can watch this video. It's a very interesting one. It's mega structures, impossible bridges, Rian Antrion bridge, and there are other types of foundations. You know, the advanced types of foundations which are used for the tall structures. By this one as well, I would recommend here. So there was the the liquefaction issue was also there. People want to go into the offshore environment. In offshore environment, how the soil is strengthened. Please unmute your mic. Mute your mic, Ashad Zawar, please. Please mute your mic. Okay, so that was just an introduction that what we are going to experience in our coming lectures. I hope that you will enjoy and you will learn the upcoming lectures which is related to the shallow foundations and the deep foundations. Thank you very much, and you can write P in the comment box so that I can note down your attendance, and then if you want to leave the class, then you can leave the class. Sorry for the inconvenience about the sharing. I usually keep the internet package up to date as well, but there are a few issues with the internet in Earthquake Engineering Center, so please apologize for that.